Now let's understand concept of limits. Now this is a bit, attention seeker limits. Okay, so let's see how this is going to take our nerve. Now the point is, if there is a curve, okay, and let us assume there is a point A. This is A. When you put A in the curve, you get FA as Y. Obvious? Obvious? Now let us say if this is A and the gap is H, this is H, then this will become A plus H. Obvious? Now you put A plus H in the curve, you'll get FA plus H. Remember in previous class I told you how to find A plus, FA, FB, FC, whatever you find. Now, if I have to find derivative, yani ki slope of the chord, what I will say? I will write this. And this, we are familiar to this. This is the gradient. Okay. Now, if I say, okay, fine. What is, if I write fx, where limit, I'm writing this limit x tending to a. X tending to a, which means I'm going to put a over here, which is not actually a, but my intention is to reach a. Reach at point A. My x is intending to reach A. This approach of x, which is very close to point A, okay, which means I'm going to reach, I'm just about to reach point A. I haven't reached at point A. That is why we write limit extending to A. Otherwise, if I reach A, I will definitely write FA. There's no question.
Yeah.
But if I'm not able to reach A and I'm just ahead or I'm just away from A, I write limit extending to A. Now your question may be, sir, how I will know whether you are about to reach A or you have just left A? Okay, this is the destination of A. If I'm over here, I'm just about to reach A. If I'm over here, then I will write I've passed A, but still I'm very close to A. So for this point A and for this point B, the method to write is, so if I zoom in this one, okay. So I hope this is not very hazy for you. You can comfortably see. Good. Okay. Now, if I pick a point just very close to this point and very close over here, okay, this can be regarded as A minus, yani something less than A. And this will be regarded as A plus, which is something just more than A. Sometimes we write FA limit, sorry, FX limit x tending to A plus. And sometimes we write x tending to A minus, which means left hand limit or right hand limit. Whether we are just ahead or we are just before. Okay? So just give heading limits, make this short note, and then we will proceed.
But
yes, please ask. Okay. Please ask. Anything, please ask.
No, I don't know how to phrase it. Like,
Acha, you don't know how we are going to use this concept?
No, I don't know how to like. Yes, firstly that, because like does
that I haven't taught you till now. I will teach you that.
Does FX go through A, or is it like an asymptote type of situation where it's almost at A but never really touches A?
Yeah, so it is not asymptote. Asymptotes are actually tangents, those which are actually having slope very close to x. So that is your logical point. But this is the situation where function is, where my domain value is just before that exact x value. For example, let us say, हम थोड़ा simple कर लेते हैं. Let us say this is 3, not A. This is confusing. A is confusing. So this is 3. Okay, and I am sitting at 2.999999999.
Right.
Which is not 3. So I will write limit, instead of writing 2.9999, I will write limit x tending to 3 minus. That's it.
Okay.
It is the way
So
of writing that thing.
so that's your limit is a range. It's not a line that passes through the point that
Yes,
you've
it
set.
is a particular point. It defines that still I haven't reached over there. That's it. I'm talking
Okay.
about same point, but I'm not standing over there. I'm talking about
Okay.
same point, but just before that. For example, if I ask you, this is y is equals to x square. Okay? I tell you y is equals to x square. So if I ask you what is the value of this function at 3, you can straight away give me the answer. You will say, sir, 3 square. So this is your answer, sir, 9. Isn't it? Very fast. But what if I ask you, please tell me the answer just before 3? In that case,
Right.
my way of asking will be find answer to this.
Okay.
Fx. And I will tell you that fx is this. This
So
is my
it's
way.
not a range, but it's not a line either. So it's a
Yes, it's not.
point,
This is not a line. Yes, this is not a line.
but it's not a range. Like
It's not a
it's a
range.
point.
Yes, it
Like
is not a range. It is a point
it's a
very close to
it's a
3.
definite point. Okay.
Yes, yes,
Okay.
yes.
Okay. Okay. Got it. Um, Okay.
Now, if you see this sentence, fx is set to converge to a as x approaches small a. As soon you reach over there, okay? So it is going to approach at a. When we write limit extending to a, it means we are going to approach a. Like if I talk about if this is 3, and I say I'm putting 1, then I'm putting 2, then I'm putting 2.5, then I'm putting 2.7, 2.8, 2.9, 2.99. So I'm continuously moving towards 3. So when I write limit extend to a, it means I'm very close to a, very close to a, which can be 2.99999. Okay. You'll understand this better when we'll go towards questions. So this was my basic, I want to give you a basic understanding of limits. Okay.
Yeah.
Okay. Now let us come to a point of discontinuity. Let's understand what is discontinuity. If someone draws a curve like this, can you see something suspicious in this curve? What is this? Have you seen ever have you seen this? A missing
No.
point, a hole on a straight line. It's
No.
literally a hole on a straight line. I'll show you.
Oh.
Yeah. Isn't it beautiful? You haven't seen this, no? So maths can bring like this. A missing point. And please see another great thing. The point is actually lying over here. Drop down. Cool,
Huh?
huh? Isn't it cool? This point is missing. X is equals to 0 is missing on this curve. This function
Oh.
will
Yeah.
not be a defined function if you put x is equals to 0. You will say, sir, how is it possible? I'll say, please check this. Put x is equals to 0 over here, and you will enjoy the concept. You put x is equals to 0. The moment you put x is equal to 0, fx will become not defined. Isn't it?
Yeah.
And that is why when a graphic curve mathematician will draw this curve, they will put a hole over here, which means that this curve is defined everywhere except x is equals to 0. So you can see 5 written over here, but x is
Yeah.
hollow. So no x can be defined over here. Okay.
Okay.
How to write this in mathematics? In graph to chalo theek hai, samajh aa raha hai. How to write in mathematics? In mathematics, we write it like this.
Oh.
That fx is not defined at x is equals to 0. Okay. This is a special case. Special case, there will be many cases such like this. But if you had this function can
Yeah.
be rewritten like this. You can rewrite this function. You can take x common and you can write it like this. After writing it like this, you have to mention this so that this can define boundaries of the function.
All right.
Okay. Please take this example. Please write example. Please write
Yeah.
example. And this is point of discontinuity.
The missing point is the missing point is the point of discontinuity.
Yes, exactly. The missing point is the point of discontinuity. Correct. So the function is everywhere continuous, giving you
Yeah.
values everywhere except at that point. And that is why it is known as point of discontinuity. Very well said, Beta. Now, as we see the problem is function is non-continuous at point x is equals to 0. So how
Yeah.
to incorporate that? Because maths cannot deal like this. Maths needs certainty at everything. So we have to define this also without committing an error. So this is the solution. I'll use another color which will differentiate things. Just a second. Yeah. So if I have to define this, I will write same function like this. And this is correct. This is not wrong. How beautiful is this? Please have a look. I'm putting x is equals to 0 and it is not giving me a not defined situation. Isn't it cool? This is how mathematics deals with this. See, over here, it was, mathematicians were crying a lot. I cannot put f is equals to 5 because it is going to give me this situation. Huh? Everyone was crying with this. Now, the moment you say this, everyone is so happy. Okay, 5 is the answer. Seems cheating? No, not. I'll tell you why this is not cheating. Why?
Because
Because
you just the
this,
number right before
yeah,
zero.
this guy is not saying that I'm sitting on 5. This guy is not saying that this guy is not saying that I'm sitting at x is equals to 0. The guy who says limit x tending to 0 means he is very clearly telling you either I am reaching from this side towards x or I am reaching from this side. So literally he says this and this. Getting it? Not not at x is equals to 0, balki he is coming from this side or this side. From both the
Yeah.
sides he is coming. Because he is not clarifying whether I'm at x is equals to minus or I'm x is equals to plus 0. But yeah, from both the sides. So if you move just away from x is equals to 0, you'll reach 5. Of course, yes. If you move just before x is equals to 0, you reach 5. So that's the perfect answer to this. The function will achieve 5 the moment you try to reach x is equals to 0. The only thing is you
Right.
should not stand at x is equal to 0. Is that
Yeah.
making sense to you?
Yeah. You have to be either right before or right after.
Exactly, exactly.
Yeah.
So just below that,
Okay.
please write this. So this is a proper explanation for you to understand limits. This is a proper example. So let us try at least one example, and it should be a good one. So I'm going to pick this. You want me to explain one and then you would like to solve, or should I just give you one?
Yes. Yes. Please. Please.
Should I explain? Okay, I'll do that. Okay, no problem. Now you see, first of all, we will solve this algebraically. Otherwise, if you directly put x is equals to 3 over here, what will happen? Same disaster will happen. In denominator,
Yeah. And
like 0, and then things
yeah.
will go in similar way. Okay, so what we should do, what we did over there, we should take x square minus 3 square upon x minus 3. Okay, this can be written as x plus 3 into x minus 3, correct? Whole upon x minus 3. So x
Yeah.
plus 3 can be cancelled like this, and you will get x plus 3 as the final value. Right?
Okay.
The moment you'll put a result to that, it will give you 6. Because now you can safely put x is equals to 3 over here. Because
Ah. Okay.
life is simple now. You can
Right. Yeah.
easily manage that.
Yeah.
I think now you can easily solve this one. This is a simple cakewalk, nothing big.
Wait 1 second. Um.
Perfect. Okay.